OSU's own Joshua McGuffie. Many of you know him, I'm sure. Master's candidate in our History of Science program. I just want to say a few words about the Resident Scholar program. It's been in place a number of years. Currently it is funded by the Friends of the Library Fund. So that is a general purpose fund that literally has thousands of donors to it. So very broad-based support for the Resident Scholar program as a result. And I just want to acknowledge Library Administration and their ongoing support for our program. Josh is the second of this year's class of resident scholars, and I'm going to ask Chris to say a few words about him and do a formal introduction, and then we can get rolling.
Thanks, sir. That won't be too formal. So about the Resident Scholar Program, it's been going on since 2008, but 2 years ago we decided that what we wanted to do as part of this is to try to reserve a slot for a regional graduate student. Somebody who's going to have to be a good proposal, obviously, we're not just going to give money away, but we're hoping to support a regional graduate student. So last year, Chris McGuffie from the U of O was the recipient of that money. He did a very interesting project talking about some of the extension agents that worked here once upon a time and kind of their engagement in geopolitical affairs. So this year, Josh is the latest of several resident scholars to use our nuclear history collections. And his topic is pretty interesting. Interesting on a lot of levels, especially for those of us who work in SCARC. So last spring, the whole department shut down for 2 days, and as Larry described, he used a SWAT team method to clear out a garage in Eugene. It was filled full of file cabinets of stuff, and I was part of that. I was part of the effort to get the stuff out of the file cabinets in the boxes, transported back and forth from Eugene, and 6 van trips I think we took. But Josh is the first person to dig into that stuff. And he certainly hasn't seen all of it because there's a lot, but I think it's part of the centerpiece of his talk today, and I'm very interested to see what the product does from garage to scholar. So with that, Josh.
Thank you, Chris. Well, good afternoon. I'd like to start off by thanking SCARC and thanking the library. This was a wonderful opportunity to spend a lot of time in the archives at the library here this summer. And part of the funding also helped me with a trip up to Hanford, so I got a little bit of a research journey out of it as well. Many thanks to Chris, who helped me out with recording and technology things, and many thanks to Anne and Trevor, who answered so many questions and were just exceptionally helpful this summer. I will focus a lot on the Haber collection, which was occasionally a joy to go through and occasionally, let's say, less than a joy to go through. There's just lots, there's so much there. And so before I start today, I'd like to just say a little word about what this project is and where it is, and then go from there. I'm in my second year of my master's here at OSU, and I'm hoping this will turn into a master's project. And so I'm trying to situate what environmental scientists and biologists at Hanford said. There's a huge historiography about Hanford, which I won't bore you with. Not that it's boring, because it's not, it's really quite compelling. But there's a huge historiography at Hanford. What I've found is that I think the historiography has treated scientists who worked at Hanford as useful data creators, and very occasionally as useful for their opinions, but mostly as data creators. We're thankful that we have these people collecting data about how polluted Hanford is. Now let's get on with our story. Today's talk hopefully will illuminate their stories a little bit more than the historiography has generally. So hopefully I haven't trashed everybody who's written about Hanford. That would be awkward. I'll begin with a quick apology, which is I'm going to read to you. I'm sorry. You always get to choose between being engaging and making eye contact with people, or getting your words exactly right. And I would like to try and get my words exactly right today. So hopefully it won't be too long a paper. One landscape, many stories. Lots of ink has been spilled in the last decades about how scientific communities create knowledge. These range from in-depth laboratory studies to musings about the role of field stations. Today, I would like to talk about a scientific community focusing not on the knowledge they created, but rather on the more than scientific narrative that they crafted. The scientific community in question is made up of the biologists and environmental scientists who worked at the Hanford Nuclear site in south central Washington state during the 50s, 60s, and 70s. They sought to understand the radioactive landscape that grew up around the weapons-grade plutonium production process at Hanford. Their stories gave the land meaning in its atomic context. So, for example, worried that the public was concerned about atomic safety and radioactive waste, they called the land safe. Then, as they moved their research out of the lab and onto the land, they encountered a landscape that had sat unused for decades. This land, whose native flora and fauna had rebounded to some extent after decades of grazing, they called pristine. These narratives grew up even as the core of the Hanford site came to be characterized primarily by its radioactive waste. By the time plutonium production ended in 1987, Hanford semiotically existed as a bifurcated place, cast by outsiders as a land of contrasts. The central core eventually housed 4 Superfund sites. Then, in 1999, the narratives created by biologists and environmental scientists became incarnate in Hanford Reach National Monument. Today, the safe and pristine National Monument abuts the nation's most polluted place. I just have to point to these 2 pictures. Here we have a picture from the Fish and Wildlife Service of the National Monument, and it leaves out the core with the Superfund sites. And here we have a picture from the Department of Energy, which leaves out the National Monument. It's this fascinating, it's as though when you speak to one side of the divide, the other side doesn't exist, at least in my experience. I argue that to understand how Hanford became 2 very different places, we must pay attention to the stories that were told by biologists and environmental scientists over the course of the site's history. So, we will look at 3 Hanford scientists to see the environmental narratives they crafted. Then we can see how these developed and parse them for meaning by trying to make sense of the situation today. More than scientific. A variety of scientists at Hanford helped to create the more than scientific narratives that came to characterize the place. Herbert Parker and Dick Foster, both of whom began their work at Hanford in the 1940s, both forcefully advocated and artfully developed a safety narrative at Hanford. William Rickard, who was a generation younger and began work at Hanford in 1960, contributed to a narrative that followed on safety's heels, one that called the land pristine. These 3 scientists did not sit down and write lengthy environmental tomes, nor did they make public moving journals, the likes of which, something like John Muir published, right? They didn't do that. Their stories are keywords and tropes hidden among a sea of bureaucratic weeds. Picking out their environmental narratives largely means finding a piece here and a snippet there, interpolating their understanding of the land between otherwise miscellaneous remarks. Though they are sparse in comparison to scientific verbiage, these stories can be teased out. So our first scientist, Herbert Parker, a needful vigilance. Herbert Parker came to Hanford in 1944 to lead its radiation protection program. An Englishman by birth, after taking a bachelor's and master's degree in physics from the University of Manchester, he emigrated to the US to work at Swedish Hospital in Seattle in their nascent radiation oncology unit. During World War II, he worked as a health physicist for the Manhattan Project in Chicago at the Metallurgical Laboratory. When he came to Hanford, he headed up the Health Instruments Division. He disliked the division's confusing name, Because what, after all, is a health instrument? Parker felt that he protected people from radiation. And so later in his life, he lamented that radiation was a dirty, classified word when Hanford started. Parker believed in the atomic enterprise at Hanford and was proud of his work. He wanted to control radiation, not to hide it under a bushel. To be fair, the plutonium production operation during Parker's first decade made his job a complex one. Hanford spewed out radioactive pollution at a staggering rate. The plants that chemically separated uranium from plutonium belched out hundreds of thousands of curies of radioiodine each year during the 40s. A curie stands for, it stands for a decay of 37 billion atoms per second. So if you think of hundreds of thousands of billions of decays of atoms, each creating one type of radiation or another, that boggles the mind, right? Parker had a complex job. During this time, Hanford's early years, Parker zeroed in on a twofold goal for himself and for the health physicists working with him. First, he wanted to avoid, or at least competently handle, any acute radiation exposure that might happen to workers at Hanford. Second, he aimed to understand pollution in order that chronic exposure to the local population not become a problem. Parker has been roundly criticized for failing in the second task. Indeed, poems have been published about his blasé attitude toward radioactive pollution. To be sure, Parker was a company man. His prestige as a health physicist rode on Hanford's smooth operation, or at least the perception of its smooth and safe operation. But he was no devil. He really did believe that a comprehensive radiation protection program could keep Hanford safe. Some examples bear witness to this belief. Parker chafed in 1949 when superiors at the Federal Atomic Energy Commission, the AEC, and Air Force brass conducted a now infamous test called the Green Run. In this test, they purposefully released up to, no one really knows for sure, up to 8,000 curies of radioiodine and up to 16,000 curies of radioxenon in a single night. The winds that night were erratic, blowing these radioactive plumes over Hanford and nearby towns. Then it snowed. The snow speeded the deposition of radioiodine on plants used for livestock forage. In spite of these atmospheric contingencies, Parker towed the company line in his monthly environmental report for that December. He argued that no samples taken after the test showed explicit danger to humans. However, he not so subtly inserted this opinion in the report. He said, widespread contamination by iodine-131 occurred as a result of the specially requested dissolving at short cooling time. The prediction that this could be accomplished with negligible risk to personnel was supported by the experimental observations. However, the resultant activity came close to significant levels, and its distribution differed enough from simple meteorological predictions that the Health Instrument Division would resist a proposed repetition of the test. Perhaps this is not a stinging rebuke, but for 1950, as the Cold War ramped up, and after it was known that the Soviets had tested their own atomic bomb, Parker's insider critique should not be overlooked. His words reflect an attitude of responsibility to his coworkers and an acknowledgement that scientific predictions are not always right. He carried this attitude of company man responsibility with him when he was promoted to head the Hanford Laboratories in 1956, a position he held until 1965. As head of the labs, Parker encouraged and oversaw a comprehensive environmental monitoring program through the renamed Radiation Protection Department. They conducted regular radiological surveys of the whole Hanford site, annually creating reams of data regarding Hanford radionuclides in the air and water and ground. Michelle Gerber, a contemporary Hanford historian, remarks that Hanford's environmental monitoring records were among the most complete ones in the world. Parker's departments knew exactly when too much radiation was being emitted from plutonium production, which was often. Parker took his scientific charge seriously, though, and he saw his position expansively. As OSU History of Science graduate Eric Ellis notes, he pushed hard for the biology department at Hanford to expand out of the lab and further into ecology research. So, how did Parker's early experiences as an applied scientist at Hanford and his later experiences as an administrator mold his view of the land? To be certain, Parker supported the radioactive landscape at Hanford. A Manhattan Project alumnus, he expressed awe at the technological feats accomplished there. He was a positivist. In 1971, after he was retired and only worked on a consultancy basis, he gave a short speech at the dedication of the new Life Sciences Lab building. Without the benefit of hearing his inflection, it's hard to tell if he's being reflectively sad or zestfully defiant when he says what you're about to hear. I suspect the latter. He's agitated that the US atomic program has gotten a reputation for environmental indifference and degradation. Speaking almost exactly a year and a half after the first Earth Day, Parker remarked, "This country behaves as though it discovered the words ecology and environment about 5 years ago. Since that time, the AEC has been clobbered by its critics on all sides because it is said to have done a fairly respectable job of protecting workers in the atomic plants, but has paid no attention whatsoever to ecology and the problems of radiation in the environment. The program that has been operating at Hanford for 20 years is a complete refutation of this, which deserves to be better known. The principal programs that were started 20 years ago and have been maintained to the present time were in fact mainly concerned with the environmental problems." An important theme about the landscape leaps out from Parker's remarks here. The landscape is comprised, to him, of the sum total of human, so in this case radiological, interactions with land. So Hanford is a place ideal for environmental study because scientists need to know the land in order to keep it safe. From Parker's no doubt biased perspective, he did after all lead the biologists and the environmental scientists, radiation helped Hanford get ahead of the ecological curve. Those clobbering the AEC were just hopping on the green bandwagon. In vigilant radiobiology and radioecology, Parker saw salvation for a technocratic nuclear future. To be sure, not everyone in Parker's day shared his positivism, and objectively speaking, plutonium production at Hanford did pollute the land. In many ways, central and eastern Washington and Oregon were turned into sponges for untold curies of a variety of devastatingly harmful radionuclides. But the goal here is not to judge Parker. His view of the landscape at Hanford as ecology's proper home matters most in this story. Next, Dick Foster, Safe by Any Name. This is Foster here in this wonderful TV program that was produced by General Electric for local television in the Tri-Cities. And it's just, this is what a 1950s scientist looks like, right? It's fantastic. Foster, Safe by Any Name. If Herbert Parker argued that Hanford was by nature an environmental place, Dick Foster took a slightly different tack, claiming that it was a safe place. Foster's experience differed from Parker's in that he was homegrown. Foster studied at the University of Washington School of Fisheries under Loren Donaldson. Donaldson had organized X-ray studies of fish at UW during World War II in order to begin research on how Hanford's reactor effluent might affect young salmon in the Columbia River. Foster moved from Donaldson's lab to the newly built, though modest, fish lab at Hanford in 1945. It was a Quonset hut. 7 years Parker's junior, Foster very much grew up at Hanford. This was his first proper job outside university, and he was mostly by himself in the fish lab. He spent his first years exposing salmon and whitefish to reactor effluent. The 8 reactors that operated at Hanford used Columbia River water as coolant. It passed through their highly radioactive cores, and the resultant effluent was released back into the river after having sat in cooling trenches for just a few hours. Hanford's fish lab was next to the F reactor, since his research required access to its radioactive effluent. Though Foster threw himself into his work at Hanford, he continued to collaborate with his colleagues at the University of Washington. In 1947, he traveled to the Pacific Proving Grounds with Donaldson and others as part of the Bikini Resurvey Project, assessing the effects on fish of Operation Crossroads nuclear explosions the year before. Foster's work at Hanford and his work through UW occupied a liminal space at this point. Was he a biologist doing fish research, or was he doing radiation monitoring? In the early Hanford days, under the Manhattan Project, Foster simply did his research without really making a distinction. But as Hanford's scientific administration became more complex, specialized, and disjointed, Foster found himself gravitating towards radiation monitoring in the Environmental and Radiological Sciences Department, though he did still perform some applied research for the Biology Department. The boundary between the two was porous. Foster would straddle the divide and eventually move up to an administrative position as second in command of the Environmental and Life Sciences Division, which in the 70s oversaw biology, ecosystems, and radiation sciences. He retired in 1979, having spent his whole career at Hanford, though after retirement he served as a scientific advisor to the National Council on Radiation Protection. Foster brought a subtle and almost religious zeal to his role as a scientist and radiation monitor at Hanford. Subtle in that he was a scientist, and he communicated not loudly from a stump, but rather quietly amid piles of facts and figures. Religious in that he evangelized for Hanford's safety unceasingly. He was a true believer in the atomic project. For example, in 1950, he was asked by a superior in the AEC to create a quick and straightforward report about the effects of a reactor failure on the Columbia River. He typed up a short response blithely titled, "A Crude Guess as to the Effect of a Pile Explosion on the Aquatic Life of the Columbia River." He acknowledged that radioactive contamination would be a problem. He then went on to muse, many of the organisms in the Columbia would be afforded considerable shielding by the riverbank, by the topography of the land, and by the depth of the water in the river itself. In a worst-case scenario, should the Columbia's food chain be disrupted by lower aquatic organisms dying en masse from radiation, he continued, nearly normal conditions would probably be restored in about a year's time from reseeding and migration. This in spite of the fact that he estimated that 100,000 valuable juvenile salmon might be wiped out. So, in Foster's back-of-the-envelope view of the land at Hanford, the topography itself would protect the biota from a meltdown. Even those parts of the ecosystem that were wiped out could rebound quickly with some help from the AEC. Foster did not just deal in internal memos and reports, though. He appeared on the Hanford Science TV program in 1957 to describe his work monitoring effluent. He confidently explained that the amount of effluent picked up by local fish in the Columbia was not at all hazardous, and from this angle, the operation of the plant is quite safe. This experience was an entree into public speaking for him. As an administrator, he would often address the public. In 1971, just a few months after Parker dedicated the new Life Sciences Lab, Foster gave a presentation to the Washington State Ecological Commission, which was titled more carefully than his quick reflections on the reactor meltdown. In this talk, Effect of Hanford Reactors on Columbia River and Adjacent Land Areas, he described in no uncertain terms how utterly safe Hanford was. He concluded the lengthy talk by saying, quote, "Comprehensive studies over more than 25 years have shown that the radiation doses received by the public have been well within the guidelines, and that no discernible radiation or thermal effects have occurred to the valuable populations of fish and wildlife." These tastes of Foster's in-house and public declaration show his commitment to building the safety narrative at Hanford. His story makes claims somewhat larger than Parker's, who no doubt also thought that Hanford was safe. In Parker's narrative, Hanford is a place of opportunity for applying environmental science to radiological problems. For Foster, the radioactive landscape is totally natural. Foster refers often to federal radiation exposure guidelines, whose history Dr. Hamblin treats nicely in his book Poison in the Well. Exposure limits, as he points out, are negotiated, man-made guidelines for how much radiation is too much radiation for individuals and populations. But to Foster, they were written in stone, even though they changed significantly over the course of his career. Using them, along with his own fish studies, he did not have to describe Hanford in statistical or propositional terms. Hanford was not safe for a plutonium production site, nor was it safer than other hazardous workplaces. It was simply safe. The river, the air, the land, all safe. Therefore, Hanford as a radioactive landscape could be integrated into normal, everyday human existence. Our last scientist, Bill Rickard. William Rickard created a different narrative about Hanford than Parker and Foster because he approached the land in a very different way than they did. He started at Hanford in 1960, again a generation behind Parker and Foster. Rickard was a terrestrial ecologist. He started at Hanford doing both basic and applied radioecology in the biology department. He had taken his PhD at Washington State University under well-known ecology professor Rexford Daubenmeier. Daubenmeier had focused much of his research on defining biomes in the Pacific Northwest, and so even though Rickard was from Colorado originally, he had been immersed in Washington's ecological landscape through research. Hanford, for him, represented nearly unlimited field study possibilities, making it a job at the site much more alluring than classroom teaching. 3 important administrative events took place in Rickard's first decade at Hanford. First, in 1962, at Parker's suggestion, 120 square miles of the site was fenced off and set aside for future ecological research. Second, the first ecology lab burned down in 1964, forcing, in some measure, the shift from lab-based research to land-based research. Finally, in 1968, the biology department was broken apart to create a separate and independent ecosystems department, whose terrestrial research would largely focus on the newly minted Arid Lands Ecology Reserve, lovingly referred to as ALE by Hanford scientists, which was that 120 square mile plot that had been set aside in 1962. ALE would become the locus of Hanford's participation in the International Biological Program. The IBP had been inspired by the International Geophysical Year, sorry, alphabet soup. And inspired by that, the IBP looked to create an ecological snapshot of the world's ecosystems. ALE was designated a site for desert and grassland biome studies. Most importantly, though, for the Hanford scientists and for Rickard, funding from the National Science Foundation came along with participation in the IBP. So, by 1971, 11 years into Rickard's tenure at Hanford, 26 discrete ecological studies were taking place on ALE. Rickard and his colleagues walked the land as they studied it. They conducted research to produce climatological and ecological baselines that could be used for long-term studies. They mapped soils and geologic features. They defined the water table and studied groundwater flow regimes, especially focusing on ALE's 2 perennial springs. They took faunal surveys and mapped the distinct zones of the shrub-steppe ecosystem that covers ALE. Rickard was particularly involved in beetle studies and the study of energy transfer through biomass. He walked from the base of Rattlesnake Mountain, which dominates ALE, to its 3,500-foot high point countless times, taking soil and plant samples. His sense of the land came from being on the land. His narrative, then, is the first we encounter that focuses on the land itself rather than on the land in relation to radionuclides. Rickard made the transition from working in a department interested basically in radio ecology to a department focused on just ecology. He would need new words to describe Hanford. He looked around for them, though he was not the first person to call Hanford pristine. That was his supervisor, Tom O'Farrell, who did so in a 1971 study entitled Cattle Grazing on a Pristine Grassland. Real moon stuff, right? Maybe if you're an ecologist. Ale had sat more or less untouched since 1943 when it was incorporated into Hanford as a buffer zone. It kept snoops out, and in the event of an accident would hopefully keep dangerous radiation in. Ale had been fenced off from the outside. This ended large-scale sheep and cattle grazing. So, in spite of the occasional rogue cattle that found their way onto free government forage, the native shrub steppe vegetation began to rebound. Grazing, of course, creates constant disturbance that favors invasive annual grasses. At Hanford, it's cheatgrass and Russian thistle that we all know from the movies rolling across western towns. By calling ale pristine, O'Farrell pointed to the native habitat regeneration that had been taking place under Hanford's regime of benign disuse. Rickard picked up the pristine ball from O'Farrell and ran with it, both scientifically and semiotically. He would conduct a series of grazing studies over the 1970s, treating ale's pristine fauna as a baseline according to which grazing damage and habitat restoration could be quantified. Rickard did not just perform studies, though. He wrote prolifically. In a piece for the Forest Service in 1972, Rickard called ale an island of natural vegetation, home to undisturbed stands of several typical shrub steppe communities. When the whole Hanford site was federally designated a National Environmental Research Park in 1977, Rickard remarked that today the only sizable acreage of Washington steppe land in nearly pristine condition exists on the Hanford site. Rickard had continued to work on the rest of the Hanford site during the 70s, especially doing biotic surveys in the radioactive waste ponds next to the separation plants. So he knew the whole site and did not call ale pristine in a vacuum. Indeed, for him, Hanford allowed ale to be pristine. Rickard's story, then, is one of an atomic landscape that stands pristine amid a sea of ecological degradation. Hanford's removal from mundane land use saved the shrub steppe. He sums this thought up in a 1982 article in Northwest Science. Because of long-standing restrictions to public use, he says, the Hanford site has acted as a refugium for wildlife in a region that is otherwise being steadily converted from sagebrush grass ecosystems to irrigated crops. In this story, the AEC and Hanford are protagonists, and the Bureau of Reclamation and Army Corps of Engineers are the antagonists. Irrigation and dam building destroyed most of Washington's native shrub steppe over the last century. Hanford, 570 square miles in total, preserved it. From three-tip sagebrush on top of Rattlesnake Mountain, to the endemic and sensitive Piper's daisy on the flats, to the endangered yellow cress in the river. And this is yellow cress right here, which is one of Rickard's favorite plants, or so he says. By calling Hanford pristine, members of the ecosystems department, like Rickard, gave value to the shrub steppe biome and helped preserve it. So to wrap up, conflicted landscape, conspiring stories. These three narratives may seem somewhat disparate, each historically conditioned and each somewhat personal, but they share a variety of characteristics and even content. First, the words and stories grew out of scientific research. All three men held advanced degrees and were employed at Hanford as scientists. Their science intersected with their personal values and experiences to create their impressions of the land. Parker saw himself as a real environmentalist because he actually had to protect a landscape characterized by atomic risk. Foster saw the radioactive landscape as safe because it fit within standards accepted in his social and scientific communities for atomic responsibility. Rickard saw the land as pristine because of its intact biotic communities, even though it sat amid the radioactive landscape. Pollution did not have the final word for any of them. The land had value. Second, all three individuals had long careers at Hanford and rose to supervisorial roles. They spent time in the lab and in the field, but their career arcs allowed them influence. They crafted their narratives in reports, memos, peer-reviewed articles, and in some cases, pieces of not-so-subtle propaganda. For them to translate charts and tables of data into more than scientific stories, they needed time to reflect and to write. Third, they needed to make these narratives public. Their stories are not the stuff of personal late-night musings or water cooler chat. They belong to Hanford's highly regulated semiotic history. These stories made it through the barricade and off the reservation. Freed, they became grist for the public mill. They can now be deconstructed and their author's integrity questioned or accepted. Most importantly, though, these narratives can help explain Hanford as it exists today in a holistic way. If we take Donald Worster's assertion seriously that the age of ecology began in the desert outside Alamogordo on July 16, 1945, with a flash of light and a swelling mushroom cloud of radioactive gases, fueled, of course, by Hanford plutonium, then surely the site's ecological narratives must stand next to its production and pollution narratives. Having heard these stories then, hopefully it makes some level of sense that Hanford today is both a hyper-polluted collection of Superfund sites and a national monument. Environmental monitoring and protection have been part of the Hanford story, regardless of what happened in and on the ground, from day one. So has safety. Bruce Headley and John Findlay have compellingly shown that the bulk of the Tri-Cities population, Richland and Kennewick and Pasco, right south of the river, where much of the working population of Hanford live, they've shown that the Tri-Cities population took Hanford's safety for granted for much of its existence. Perhaps the creation of a national monument that encourages recreational use of the Columbia indicates that the safety story reached years beyond the Tri-Cities. Finally, the environmental scientists who called the landscape, or at least part of it, pristine, built on the notion that Hanford was special. They offered a different type of special, though. It became special for the landscape itself, but only on account of the plutonium production mission. While saving endangered native habitat that existed for thousands of years, Hanford spoiled land that will not be cleaned for thousands of years. Plutonium gave with one hand and took with the other, but it only did so through the stories of those who tended the atomic garden. Thank you.